Okay, so this is another example that's somewhat challenging. A student asked me to do, in particular, Chapter 8, question number 2 in the homework, called Trend Lines and Regression Analysis. And again, like always, this is sort of like a bare bones explanation of the theory. For a deeper theory, you might want to go to either my set of videos, which I provided you a document to find, Khan Academy, read the book, etc., ask me questions. But this is more or less a step-by-step approach with some theory thrown in. So this example, we'll begin by, they give you 3 data sets, an X and a Y, and there are a number of possible relationships between them, including no relationship. Be a straight line relationship, linear regression, multiple regression, exponential relationship. These are discussed in the book, and they want you to figure out which is which. So let's look at the first data set. Of course, it's very difficult to tell from looking at the numbers. And let's open an Excel. Could do this to StatCrunch, but not as nearly as well. Let's highlight these 2 columns of data. Let's insert a scattergram, an X and Y, I think the first one, basic one. And it looks like a straight line would not really be a good fit to this data. It's not exponential because it doesn't sort of start off slowly and then work its way up. It might be it's not a U-shape, which would be a second degree polynomial, but it might be a third degree polynomial, which actually turns out to be the case where there's like an S-shaped, which will often be the case. So you click on the graphic that was just created. That creates this option, chart design. You then go to add chart elements. You go down to trend line, because we're going to be asked to put which trend lines best fit the data. And it's best to do all of them, more trend line options. It grays out exponential because there's no way this could be exponential. Let's try linear. Click on display equation and display equation and the R squared. The R squared is a measure of how close the dots are to the straight line. Technically, it's the difference between the dot or the data point and the straight line which tries to fit it, and then it's squared and it's all added up, etc. In this case, the R squared is 0.63, which is quite impressive, but there are quite a few dots that are missing that the straight line simple model doesn't really fit. So keep in mind 0.63. Let's try, I don't think logarithmic is part of the choices, but let's try it anyway. That is a 0.54, so worse one. Polynomial. If you use a second degree polynomial, which involves only x and x squared, which means a kind of a U-shaped picture, the R squared is 0.68. If you go to a third degree polynomial, which involves x cubed, x squared, and x, this seems like the best fit, and in fact the R squared is 0.77, which is pretty high. And that's about all the choices they want you to compare. So I would say the fit is this thing here, and the coefficients are 1.029 in front of the x cubed, etc. Let's keep this in mind when we try to answer the question. So the answer to the question is which chart is the best one. It's not this one. It's not that one. It's not that one. And it's this one. This is the picture we just saw of the S-shaped third degree polynomial fitting the data. So let's get rid of these. So we're going to pick C. Pretty sure it's right. Good job. Thank you. And what the answer is, it's going to be a third degree polynomial. So it's choice D. But now the coefficients, how much you multiply the x cubed, which is the x-axis. Go back to the x cubed had 1.02. Now let's write it rounded up to 1.03. So it's 1.03. The next one is going to be minus 15.94. The third coefficient in front of the x is simply 83.06 when you round it. And finally, the constant, kind of like the intercept that we had for the simple linear regression, turns out to be minus 141.59. Minus 141.59. I did the same mistake last time. Minus 141.59. Let's check it. And it's well done. Okay, now we do the same thing for the second set of data. Well, I'm going to skip that because the second turns out to be the same as the first, and I'm not going to waste our time. Let's move on to the third one. So I'm going to pick an answer. I forget what the answer was. Let's say I think it was also a third degree polynomial, which is why I don't want to do it again. Okay, so it's going to be chart D. Done. We're erasing the graphs. Check answer. That was correct. Now they want you to fill in the equation. This would be the equation for exponential, but this would be the similar equation for the third degree polynomial. So I'm going to pick B, but I'm going to put down the wrong answers to save time so we can focus on part C, the third one. Check answer. It says no. Check answer. It says no. Check answer. And remember, these are in fact the four numbers that you need to plug in for a third degree polynomial. So it was a third degree polynomial. Finally, the third set of data. This looks like when you make the picture in Excel. Up the file. Highlight the data that we're focusing on. Insert a chart, and again we're dealing with scattergrams, which is an X and Y chart. And it looks like it might be exponential, meaning it goes up slowly, moves up very slowly, and starts going up radically, exponentially, as they use terminology in English. Click on it. That opens up. Open up chart design, add chart elements, trend line, more trend line options, and this time the exponential is an option. And it fits very nicely, the exponential. And we want to have the equation, because we'll need that to plug in the coefficients, and we need the R squared. So it's 0.93, which is very high. You can see how close the dots fit the straight line. Linear is going to be worse, only 76. Logarithmic is 0.50. That means we take a log of the data. Polynomial of order 2 is 91. So it's 93.25, so it's very close to the exponential, which was 93.34, but still the polynomial is slightly worse, so the exponential is still the winner. They may give you a power, I'm not sure if the book discusses this, a power function, which is even lower. So the winner is exponential. I should point out to your theoretical edification that even though the polynomial is very slightly lower, polynomial is, no, I'm sorry, the exponential is the best one. So basically we have to remember 3.01 and 0.176. So 3.01.17. 3.01.17. Where are we? 3.01. Yeah, this is the one, exponential. Check answer. So we know it's exponential. Now we got to type in the numbers. So it's 3.01, I think I said, and 0.17 is the exponent. Those two numbers will create that straight line that seems to fit the data very well. And I think we're done. We're done. Okay, I hope that was useful. Like always, of course, if there's any additional question about the mechanics or the theory, you email me and I will get right back to you with either a one-on-one meeting or some answer.